dm. Okay, just a minute. Yeah. See, when you have a rod, and what we do, because you have to choose a very, very small element so that you can integrate it from its limits. When you integrate from its values, whatever are the values that you have chosen, you can put it in the formula. See, the formula that we have for the moment of inertia is, center of mass is cm is equal to integral of, now see, for the mass you have dm, x square is still there, divided by integral of dm. Look, let us solve the upper portion first. Integral of dm x square, this part. This part let us solve first. Now look here. What is dm? Dm is a very small element that you have taken. That mass is dm. A very, very small element from this rod you have taken. Now I'll tell you, if we are taking this rod, where we have to always define an axis in the rotation terms. Let me draw the axis. Let me draw the rod first so that things are a little clear to you. What we do, we have taken up the rod. Now here we have to determine an axis. Here we have determined the axis. Axis is perpendicular to the plane and passing through the center. This is perpendicular to the plane and passing through the center. Perpendicular to the plane and passing through the center. Now the complete length of the rod is L. This is the complete length of the rod. Now what you do whenever you have chosen an axis, that axis actually acts as the origin, as if this is the origin of the graph, though it is in reality an axis. Axis means how the body will rotate or around which the body will rotate. Like if I say this is a circle and this is the axis of rotation. Okay, this is the circle and this is the axis of rotation. So this is how it will be rotating. Okay, this is how it will be rotating if this is the axis. But if I say, let's say this is the axis of rotation. So body will be rotating like this around the axis. The body always rotates around the axis. Okay, now here what do we have to calculate? We have to find out the center of mass. So what we do here, we first choose this. We first find out the value of this dm. What exactly is this dm? Then we'll be able to write down the rest of the things that are present. Now see here, or in fact here you can even avoid this axis term. First let us find out the value of dm, then you can understand this. Otherwise this will be a little confusing to understand. First let us find out, let's go by the formula. Let's try to solve the formula. A very small element we have taken, that whose mass is dm, whose length is dx, which is at a separation of x from the origin. Now look, if I say what is the mass of length L of the rod, mass is capital M. Mass of the rod of length L is capital M. Now, if I say what is mass per unit length, mass per unit length, that is M by L. Okay, mass per unit length is M by L. Now, if I know something for a unit, I'll be able to calculate it for the entire thing. Like if you know 10 pens cost rupees 100. So you know one pen will cost 100 by 10. That's how we do, means 10 rupees. Now, if I know the cost of a single pen, I'll be able to calculate the value or total price for 1,000 pens also. So if I know mass per unit length, means for, I know what? I know in 1 meter, M by L length is present. So which length do I have to find out? I want to know what is the mass of length dx of the rod. Dx means I have taken a very small portion. So if for unit it is, then for the length it will be m by l dx. What is the mass of length dx of rod? Mass of length dx is nothing but dm only. Now if we put the value here, also one more thing. Integral of dm will give you mass only. Now let's put all the things. Center of mass if we are taking. Now from here, integral of dm, instead of dm put m by l dx. And what is left else from this? You already have this. X square was there, this. X square left, right? Oh, I have written x square, sorry. This is x. X square will come in moment of inertia. Okay, this is dm into integral of x. So this is already present. So x was already present. dm's value I have put, the value of dm, and x was already present, divided by the integral of the rod of length of mass dm. This is there. Now putting the limits. If you have a rod and you know its complete length is L. So here initially what would its length be? 0. And what would be the final length that is possible? That will be capital L. So the limits will be from 0 to capital L. These will be the limits. Okay, so now if we solve this, center of mass will be, see, m by L taken out, integral of x, it will be x square divided by 2 from 0 to L, divided by this term, that is integral of dm, which is m, right? M will be cancelled. Now what you do, you put the upper limit and then the lower limit in place of this. So this is equal to 1 by L square minus 0 square divided by 2. That is equal to L square divided by 2L, which is equal to L by 2. Means the center of mass for a rod will be exactly at its center. Length is L, separation is half. So this is how you have to utilize the variable one. You have dm. Integral of dm means you have added all these small masses. One of the masses that we took was this dm. This was one of the masses that we took, that was integral of dm. Likewise, you have such a number of masses. So when you add them, this is how it happens. Yes, have you understood this question, Zara?
Yes, ma'am.
Want to ask in between? You want me to repeat?
No.
Is it clear?
Variable is basically we don't know any values.
Exactly. We don't know any values. It will vary. Like
Only
a very
alphabet.
what?
Only alphabets, basically. Like this question.
Yeah, you will have something that will vary. Like if you have a fixed value, so you will know this is a constant term. You just have to put it in the formula and calculate m1 r1 by total mass. That way you will be able to understand it. But I'll tell you, this question is more like a derivation. Treat this question. These questions come like derivation. Find the center of mass of a rod of length L about its mean, like this it comes. So you have to show it. Okay.
Yes, ma'am.
All right. You write it, then we'll see some more things.
Can I use the washroom and come, ma'am?
Yes, yes, Zara. Just text me when you come back.
Ma'am, can you scroll it down? Can you scroll down, ma'am? Ma'am, please scroll it down. Done, ma'am.
Okay, see Zara, when you have a symmetrical system, usually for the symmetrical systems, the center of mass lie in the center only. Like if you have a ring, if you have a circle, it will lie in its center. If you have a square, it will lie in its center. If a rod is there, then it's center, like this, and the derivation we have already seen. Now there are a few questions that have come in the exam, which are a little tricky to understand. Let's discuss those. These are from a big thing, a small portion is deleted. Okay, like if you have a disk, from a bigger disk, a smaller disk is taken. So in such cases, this is asked to, the leftover portion is asked to um, mention the center of mass. Means, see, it's like if I have a disk, okay, big disk is present, and from this I cut a very small portion. So can you see this crescent part that is left? This center of mass is asked. So what we do, one method is that you calculate the remaining center of mass. You use this formula. X center of mass is m1 x1 minus m2 x2 divided by m1 plus m2. Now this is a little difficult to use. The reason is that here locating x1 and x2 will be very difficult. This is not for every portion that is present. Okay, m1 x1 minus m2 x2 by m1 plus m2. So it's better I just tell you one method, Zara, through which your questions will be easily solved. If you have a disk, okay, or if you have a sphere, so you can use the same method. What we can do, we can calculate one more method is you calculate the total center of mass of the portion, you calculate the center of mass of this portion, and then subtract. Again, best method is what you do. You calculate, you take an origin reference axis. Let's say this is our axis in the center. Now everything will be in terms of this. Okay, this is acting like the origin. This is acting like the origin. Now, when we talk about the center of mass, okay, m1 x1 minus m2 x2 by m1 plus m2 times. So, if we talk about the total mass means if I have the area, so let's say mass of the disk of area by r square is m. Okay, for the complete disk whose area is pi r square, the mass is m. Again, we'll use the same technique. So mass per unit area will be mass of unit area will be m by pi r square, mass per unit area. Okay, mass of the disk of area pi r square and mass of unit area will be m by pi r square. So unit area means in 1 meter square, how much of the quantity is present. Okay, how much it is present. Now, now what do we want to find out? I want to find out what's the mass of this cut over portion that has been thrown away. What is the mass of this leftover portion? So this is r by 2 is the radius. So I can say mass of the disk of area. Now, pi r by 2 is there. So pi r by 2's whole square will become pi r square by 4. Right, will be m by pi r square into pi r square by 4. For unit it is this. This is for 1 meter square. So for this much it will be multiply this with pi r square by 4, right? So see, what will it be? Pi r square will be cancelled. This will be equal to m by 4. Now see, m1 will be the mass of the disk. x1 at the origin, what is the separation of this bigger disk? There is no separation. It is exactly at its center. So it will be 0. The coordinate for this disk. Imagine as if this whole disk is present. So at the center, it will be 0 because that is your origin. And at the origin, what do? We take the origin to be 0. So this is equal to 0 for the bigger disk. M as the mass and 0 for the position. Then the disk. The mass is m by 4. And what's the distance? It is r by 2 from the origin. This capital R for the disk is exactly at its origin, only center of the disk. So we have taken it as R. And this is R by 2 from the origin. Now you have the coordinates. Use it normally to solve your question. Your XCOM will be M1 X1 plus M2 X2 by M1 plus M2. So this will be M into 0 plus M by 4 into R by 2 divided by M plus M by 4. So this is 0, this is MR by 8 by, this is 4M plus 1, 5M by 4. The M will be cancelled. This will be R by 8 into 4 by 5. Correct? This will be here. This will go up. The denominator R by 8 is there, divided. This goes up. So this is 2. This is equal to R by 20. So R by 20 is the center of mass when a small disk has been cut. So if it's a sphere, what you do? Volume, the mass of the disk of volume 4 by 3 pi r cube, like this. Then unit volume, then whatever you want to calculate. For disk, use area. For the rod, 1D figures, use the length. Length, area, and volume. This is how you have to put the figures. Clear?
Yes.
Okay, write it. After this, we'll see something about related to motion, movement, and velocities and all. Okay, please write it.
Ma'am, how many topics do we have in this chapter?
Please, technically, you have center of mass. This topic, this whole lengthy topic, conservation of center of mass in this only. Then you have kinematics of circular motion, like you had in the kinematics equations. And in that only, then you have few topics are there. That next topic is there. And after that topic, you have conservation of angular momentum, torque is there. And then you have moment of inertia and rolling motion. These topics are. But moment of inertia is a lengthy topic. Rest of them are not very lengthy. Center of mass is a very lengthy. Okay.
Done, ma'am. Done, ma'am. Done, ma'am.
Okay, see, let's discuss the motion of the center of mass. See, position, you have velocity, then you have acceleration. This is the sequence in which we go about for the motion of any particle. So position, did you have an off, Zara, today from your school?
No.
It was a working day for you?
Yes.
Okay. See, when we talk about the motion of center of mass, basically position is there. That is the center of mass's location wherever it is present. Now, when you differentiate position in general, also what do you get? What do you obtain? You obtain velocity. Okay. So position of center of mass is there, then velocity of center of mass is present. Now, when you differentiate the position, let's differentiate it. The center of mass. It will be M1R1 plus M2R2 plus M3R3 till MnRn divided by the total mass, that is M, with respect to dt. Okay, so mass will be taken out. Now see, individually also the masses will be taken out. M1 dr1 over dt plus M2 dr2 over dt plus M3 dr3 over dt up till nth dr3 over dt. Now look, whenever you have position divided with time, that gives you velocity. So this becomes the velocity. This becomes the velocity. This becomes the velocity. Okay, so finally we can say velocity of the center of mass will be m1v1 plus m2v2 plus m3v3 up till mnth vnth divided by the total mass that is present. Okay, so like this we have the velocities. The way you have position, same formula, you replace position with the velocity. This I'll write it a little deeply. Now, after velocity, when you differentiate this velocity comes acceleration. So acceleration of the center of mass will be you differentiate the velocity of center of mass with respect to the time. So let's differentiate acceleration center of mass. D. D will be m1v1 plus m2v2 plus m3v3 up till mnth vnth divided by dt and divided by mass, of course. Now see, acceleration of center of mass will be 1 by m will be taken out. Now masses are constant, so m1 dv1 over dt plus m2 dv2 over dt. Like this will go on till mnth dvnth over dt. So what you do, see, dv over dt is nothing but acceleration first. This is acceleration 2. This is acceleration 3, 4, 5 till nth. So when you put in the value, acceleration of the center
Your
of
voice
mass
is starting to echo for me.
right now, still,
Your voice is, yes, it's still echoing. I can hear it 2 times because it's double.
oh, wait. Just check Zara now. Is it better?
Yes, ma'am, it is better.
So this will be M1A1 plus M2A2 plus M3A3 up till MNth, ANth divided by total masses M1 plus M2 plus M3 MNth. Okay, so this is the formula of the center of mass. This is the acceleration of center of mass. Now for velocity also, M1 plus M2 plus M3 up till MNth. This is the formula for velocity, and position you already know. Nobody actually asks the derivation. Usually it doesn't come in the exam to write this, but formula based questions are there. So we'll discuss a question. You write
So
it.
the derivation is not important.
Not very important, honestly. Means in the exams, these usually do. Why am I telling you this is because when you sit to revise, you should focus on things that are very important and you should keep on noting them in your registers. No, that's why. Otherwise, see, for coming, anything can come. That's a different part, but this is not important. Formula is important. Derivation is not in this. Okay, right.
Done, ma'am. Done, ma'am. Done, ma'am.
Okay, see, this is a question based on the pulley problems. This is calculate acceleration of each and acceleration of the center of mass. See, whenever you have pulley problems, for the pulley problem, what we do, we use the concept of the free body diagram. So, what all things are acting first? This is a body of 5 kg weight. So, if I draw its free body diagram, this is 5 kg. Here above, this has the tension, and below mg is present, and the entire system is accelerating with some acceleration A. And for the second body, if I draw the free body diagram, this is 10 kg and this is tension.
Ma'am, what is the letter next to calculate the word? Sorry.
Calculate acceleration.
Acceleration. Okay, thank you.
Okay, acceleration, and this moving downwards with acceleration A. Now see, let's make the equations. Wherever direction of acceleration is there, that is taken first. Direction of acceleration is always taken positive. Now see, we write the net equation. Net equation is mg minus t is also possible, t minus mg is also possible. Either of them will be used. Now, which one is preferable? So wherever the acceleration is directed, we choose that as positive or negative. Okay, so this is t minus mg is equal to ma. Okay, tension minus mg. See, two things are possible when you have tension minus mg or mg minus 10. How do we use the laws of motion? The net force is equal to mass into acceleration. Net force is t minus mg is m. This is one equation. The second equation here, okay, this is also net force is equal to mass into acceleration. So this could also be mg minus t or t minus mg. But again, see, the direction of acceleration is taken as positive. So this will be mg minus t is equal to m A for this one. Now masses are different. This is different. This is some mass 1, this is some mass 2. If I make up the equations, this will be T minus the mass here is 5. So 50 is equal to 5A. This is the first equation. Second equation will be, this is 10. So 100 minus T is equal to 10A. That's the second equation. Now, first let us calculate the normal usual acceleration the way we have studied in the laws of motion chapter. So this will be T minus 50 is equal to 5A, and this is 100 minus T, or in fact, I'll write it like this. This is 100 minus T is equal to 10A. This will be minus 50 plus T is equal to 5A. Now let's add both of these equations. These will be cancelled because the signs are completely opposite. 100 minus 50 is 50. We are adding them. So this becomes 15A. So acceleration, this becomes 50 divided by 15. So directly we can write it as 10 by 3 meter per second square. Now that's the acceleration. See, for the center of mass, it says calculate the acceleration of center of mass. Now, individually, we have calculated the acceleration. Let's say this direction, this is going upwards. We have to do the sign convention because both the direction of accelerations are opposite to each other. So this will be plus 10 by 3. This will be minus 10 by 3 because two vectors in opposite
So
direction.
the one which is going upwards will be plus and the one which is going downwards will be
You can
minus.
change that. You can write anything, but it's just that you have to mention, like if I'm taking up as positive, I'll just mention that my sign convention, I'll just mention my sign convention will be up is positive, down is negative. That's it. If I want, I can interchange that. That's up to me. It's just that I have to mention that what have I chosen as my sign convention. Now see, everything is very clear. When you calculate the acceleration on 1, what is the mass 1? 5. A1 for 5 kg acceleration is 10 by 3 plus M2. M2 is 10 into acceleration is minus 10 by 3 divided by M1 plus M2, that is 5 plus 10. This has to be solved further also. 50 by 3. See, this part will be 50 by 3, while this will be minus 100 by 3. Yes, 50 by 3 minus 100 by 3. That makes it minus 50 by 3. Minus 50 by 3 into this is 15. So again, this is 50 and this is 3 in the denominator. So 10 by 3. That becomes minus 10 by 9 meter per second square. We've used the same formula, M1A1. See, what's the formula that we have used? We have used this formula only. Look, M1A1 plus M2A2 by M1 plus A2 plus M2. Reason this the difference that we did was for A1 and A2 we just chose plus and 1 as negative because the accelerations were in opposite direction. If they weren't in opposite direction, then we would have taken both of them positive. Got it? That you need to mention the sign convention in order to use these kinds of questions. Is it clear, Zara? This one.
Yes, ma'am, it is.
You write it properly, so little in a half a zip manner. Yes, please write it.
Done, ma'am. Done, ma'am.
Okay, see, let's see one more question. This says, now similar concept we are going to apply. Masses, let's check. Two bodies are moving towards each other. So M1 will be equal to 2
Okay.
kg. Huh?
M2 is 5 kg.
Yes, M2 will be 5 kg. Right. Now see, regarding the velocities V1, see, both the velocities are in opposite direction. Now as soon as you have the whole concept of vectors, you'll have to be very specific about the direction. Like if you wish, you can take any direction, sign whatever is your wish. But you have to mention, like if I take my sign convention, let's say I've taken right as positive and left as negative. Now, what does the sign convention actually signify? Like, look, if I was getting a negative answer, what was the direction I chose as negative? I had chosen down as negative. It means the direction of center of mass is downwards. That's why this is visible like this. Okay, so this is right is positive, left is negative. If this is towards the right, it will be positive. This will be towards negative. So this is 5 meter per second. V2 will be
In this chapter, if
minus.
anything is in opposite direction, we'll have to use sign convention.
That's throughout your kinematics, that's throughout your physics. Vectors you must have studied. Vectors have directions. So how to specify their directions in motion under gravity also you must have studied these kinds of things.
Yes.
Yes, so same like acceleration due to gravity that acts downward. So we take one direction as something. So this is the same thing. It is not nothing new that we are specifying for this chapter particularly. It's that vectors are being used, velocity is being used, acceleration is being used. So such quantities are vectors, and we cannot change the laws of vectors, the rules of vectors. So that's why we are also abiding ourselves by the laws of vectors. Okay, this is not new. This is the whole old previous concept which you have already studied. Okay, that one only we are applying. Fine.
Yes.
Now for the velocity of center of mass, m1v1 plus m2v2 divided by m1 plus m2. This will be 2 into 5 minus 5 into 2 divided by 5 plus 2. Excellent. 10 minus 10, this is 0. In this question, the final answer will also be 0. Okay, but this is a coincidence. It doesn't mean that for velocities of center of mass, it will always be 0. Because the data was such in this question that it came 0. Okay, got it?
Yes.
Write this down, then let's see forces and then conservation.
Okay. How did we get 0 in this, ma'am?
10 minus 10 is 0.
Yes, sorry. Done, ma'am.
See, Zara, in this, when we talk about the forces on the center of mass, actually there are two kinds of forces that are applied: internal and external forces. So, even to understand that, we should understand a small basic concept for it. Have we discussed internal and external forces? No, we didn't. That wasn't there in the work energy impact. Okay, if I say, let's say I have a system. System means whatever is the part under observation or under consideration. Let's say I talk about sun is there, the entire orbit of Earth is present, Earth is there. Now the sun and the Earth, they have a pulling force between them. Sun is pulling the Earth. Right now, my system is this much only. System means the part which is under my observation. I am focusing on the sun plus Earth. That's it. That's it. So, what is the surrounding then? If I talk about the surrounding means anything that is present except the system. So, anything apart from the system. If I consider the surrounding and the system, total will make up the universe. Means I can say the universe is actually equal to the system plus the surrounding. Okay, system plus the surrounding. That is what is meant by it. Now, see, if I have any force that is present between my system, within my system, let's say sun is there, earth is there, so in between them, the gravitational force will exist. So, gravitational force will be there between the sun and earth, so that will act as the internal force. This is just an example. You can even have any other example present. These are the internal forces that are acting between the sun and earth, or if there is any force acting, because these are the forces within our system. Now, if I have some external forces, means coming from the surrounding, not from your system, those are considered as the external forces. Now, internal forces do not disturb your center of mass, but the external forces definitely change the center of mass. So we need to be very careful whether the center of mass has been changed or not, or is there any outside force or not. So internal system of particles is there, but it cannot affect the center of mass, while external system of particles is still there, and it can even change the center of mass that is existing. Okay, so when I talk about the center of masses, this is a very important concept which you should know. And here we have the whole concept of center of masses conservation. Now, internal force means applied by agencies of the system. External forces are applied out of the system. This is the whole point. Got it?
Yes, that the external forces can affect the center of mass and the internal cannot.
Yes. If you see any internal force acting within the system, don't change your center of mass unless you find an external force acting. Like, let's say one more small example. Let me give you. When you write it in your notebook, you write everything in detail, means in your language, so that you remember. Let's say there's a table, and on that table there's a glass of water filled. Now, my system right now, I am focusing, I'm doing some experiments, and my system that I am referring to is the glass plus the table. The glass plus table. Now, let's say the gravitation force acts on the glass on the table, or the table exerts a normal reaction on it. All these are a part of the system only. So these will act as the, see here, these will act, N and NC will act as the internal force. Okay, these will act as the internal forces. Why?
Ma'am, your voice broke after you said that your system is glass and the table.
Okay, just wait. Now is it better?
Yes, no, no, it just broke for a minute and now it's back.
Okay, okay. See, I said that the system right now is the normal the glass and the table. So normal reaction is acting and the gravitational weight is acting. So these forces are internal forces because they are a part of the system. Now, if I, with the help of anything, if I take and push this glass, so that will act as the external force. So do you get it? System and surrounding make up your entire universe. This is how we have to solve things. Got this whole concept of internal and external forces?
Yes.
Write it. We'll practice a question based on the center of conservation of center of mass. Okay, that I'll do.
Done, ma'am. Done, ma'am. Done, ma'am. Done, ma'am.
Okay, see, Zara, this is a question from your NCRT. This is a man, this is based actually on the conservation of center of mass. Means, see, conservation of center of mass means if no external force acts in your system, your center of mass won't be disturbed because only external force can disturb the center of mass. If this isn't there, the center of mass won't be disturbed. So, see, question basically says that a man is there of mass m stands on a wooden plank of mass capital M. Small m is the mass of the man and capital M is the mass of the plank, floating on a river near its bank. Now look, what happens? Initially, this is the scene. Look at the first case. The plank is present. It's like, have you done boating? Boating. Yes, you're there. Am I audible?
Yes, ma'am, you are audible. My mic was not opening.
Okay, okay. Yes, I was asking, have you done
No.
boating ever?
No.
So, see, usually when we sit on the boat, no, when we go and sit on the boat, like the plank, if you haven't experienced, then you'll not be able to relate it much, but the boat tends to shift back. So here what happens, there was a plank. This is the man of mass small m, and the plank is there of mass capital M. And the separation is L. Your system right now is man plus plank. This is your system. Now man starts to move towards the plank. Okay, man is moving towards the plank. Right now the center of mass is here, L by 2. Because we've already done the center of mass for a symmetrical system will lie in its center. This says that the man walking on the plank towards the left. When the man reaches the end of the plank, how much distance has the plank moved? Means he has started moving, but what happens is because your plank is floating on the water, since you are trying to move forward, the plank tries to move backward. So when the person reaches the end of the plank is already at a separation from the bank of the river. It says calculate how much this is this distance that the plank has already covered. Means what is this separation? So we'll assume it to be some x. We don't know. We have to find out the x. So man plus this plank is your system. Man plus plank is the system. Now, if I talk about the first initial case, the mass of the man is m. the position of the man is L. Treat the bank of the river, the edge of the river as your origin, as your axis. So from there, try to calculate everything. If you have some reference points, it will be very easy for you to solve in the case of center of mass. This is L. For the Planck flight, mass of the plank is capital M. And what's the center of mass for it? L by 2. This much is clear for the first part, this part, before he started moving. Is this much clear?
Yes, that.
So first, let us calculate the center of mass here. It will be m1x1 plus m2x2 divided by m1 plus m2. I'll give you time to copy each and every word. Just pay attention right now. So here the center of mass will be small m into L plus capital M into L by 2 divided by m small m plus capital M. This is one part that is initially. Now second case, let us when he has moved, let us find out the dimension here. The mass of the man is still m, mass will not change. But look, the position of the center of mass of the man. This time it is not L. From the origin, how much is the man separated, Zara? You tell me. From the origin.
From the origin downwards.
From the origin, where is the man separated? Where is the man present?
Above L by 2.
Yeah, so what's the separation from the origin? Distance. How do you write the center of masses if you don't know the position then?
Using the formula.
Okay, what are you going to put in the formula? What is x1 here? Origin, from the
L by 2.
origin. See where is the man present. Look in the figure. From the origin, look. Don't look from the plank. Plank is not your reference. Your reference is the origin axis that I have told you earlier also, that always take a reference axis. Look in the figure. What can you see?
That the man is on top of the plank.
Okay. And how much he separated from the origin?
X.
X. Got it? That's it.
Yes.
From the origin only, see, this will be x, and this is the value of x that we have to actually calculate. Plank, see what has happened. I think you have not understood or what. Initially, man was there at the edge of the plank. So mass of the man was m, and from the origin, the length of the plank was a separation. I've written small m and L. Then coming to the plank's mass was capital M, and its center of mass was L by 2. Because obviously it's a plank rod, we have already studied it as L by 2. So we got this. Now the man started to move over this plank, but as soon as he reached this much part, the plank already shifted backwards. The question says find out how much the plank has been displaced. How much the plank has been displaced. So we have
How much
assumed
the
it's
man has changed position.
what?
So we have to find out how much position the plank changed.
Yes, how much position did the plank change? So we'll assume it something to be some x, but that will help us. And always have an axis fixed, especially in your rotational chapter. In the next part also that we'll see rotational equations and all, you'll have to fix up an axis. Got it? So from there, check what is the center of mass, because and treat it like the graph. In the graph, you have the main origin. So how do you solve things there? With respect to the origin you solve, right? So similarly, this how you have to calculate. So x, which is now you are right. And similarly, m2, mass of the plank is still capital M. Mass will not be disturbed. But look, the center of mass is conserved. Center of mass will not change because there is no external force acting in the system. Nothing happened, just the man moved. And man's forces that are exerted on the plank will be considered under internal because this is a part of the system. So look, it has been shifted by x and already L by 2 was present as the length. So total separation becomes x plus L by 2. If I calculate the center of mass for this one, it will be m into x plus L by 2 divided by small m plus capital M. Got it? The second part.
Yes.
Now see, both center of masses are conserved because there is no external force acting. There is, I'll just write conservation of
We are not going to solve x.
what?
Are we not going to solve the equation above, or we're just going to leave it that way?
No, first let us equate them. How will you solve? You don't have any value. Nothing is present in the question. Both the center of masses are conserved because no external force is acting. See, F external is 0. So can't we equate these two? Both are the center of mass only for the same point, and center of masses will be conserved. So we equate these two. ml plus ml by 2 by small m plus capital L is equal to mx plus mx by x plus L by 2 is equal to m plus capital M. See, the denominators will be cancelled from here. So if we write from this edge, ml plus ml by 2 is equal to mx. Let's open up the bracket here. mx plus ml by 2. So
We'll
ml by 2 will be cancelled, right? So we actually have to find out x, right? So x, let's take common, small m plus capital M. So x is equal to m into L by small m plus capital
Can we not cancel both the small m's?
small.
M. Can we not cancel both of them because they're on both sides?
Where?
ML is equal to x m plus capital M. I'm asking there.
Here. In the first step.
Yes.
In the first step, we have cancelled the denominators. What else can we cancel? Tell me.
Small m in the numerator, I'm asking.
Small m in the numerator with what? With what we'll cancel it?
The other m with x.
This cannot be cancelled. They are getting added. They're not multiplied.
Oh, okay.
Okay, see. Look at like this. Denominators cancelled because they're exactly there. They'll be, when we say cancel, cancel means two things are getting divided. Now look, m into L plus ml by 2 is equal to mx. We open up the bracket, mx plus ml by 2. ml by 2 will be cancelled because here they'll be subtracted. Nothing else is the same that can be cancelled. This is capital M. This is small m. This is L. All the things are different. So from here, we have to find out. This is the whole separation. Got it?
Yes.
It's a very important. So please write it properly and understand. And if there's any trouble with any step, let me know also. First, write the question. Note down the question.
Okay. Is this a NCRT question or is it one of the examples, ma'am?
Zara, this I don't remember. I think it is a back exercise. So this is from your NCRT example somewhere. But the question is very important. So that I don't remember. I'll have to check and tell you. But it's from your NCRT only. Okay.
Okay, ma'am. Done, ma'am. Should I draw the figure or should I skip it, ma'am?
No, no, draw the figure. Otherwise, you're not able to understand anything when you sit to revise. And in the exam also, please draw it.
Okay. Done, ma'am. Done, ma'am.
Yes, completed, Zara?
Yes, completed, ma'am.
Okay. See, conservation of momentum of center of mass. I think this is the last topic also. Conservation in your center of mass. And I'll also stop here only. Conservation of center, momentum of center of mass means, see, we have calculated so many things. Position, then velocity, then acceleration, then forces are there. If acceleration is there, force will be there. If forces are present, momentum will be there. So all these are connections. So what happens? The conservation of center of mass is there. Conservation of momentum of center of mass means the if your net external force is zero and all, means if the net external force is zero. This is also known as an isolated system. So in your exam, if the term isolated system is mentioned, just understand that external force is zero. If isolated system term is mentioned, because in NCRT this term is used in the context also. So conservation of center of mass means the total momentum, the net momentum will be equal to individual center of mass. Okay, I've written the isolated system here. Isolated system basically means the net external force is zero that is acting in the system. Okay, so this is a question. This says if the child jumps off the car towards the right with a velocity u with respect to the ground, find the velocity of the car after the jump. Basically, child is jumping off the car. He is going out with a velocity u. So momentum of the child, if I take, it will be mass into velocity, that is mu. Then it says the car has the mass m. We don't know its velocity. Let's say its velocity is v. It says find the velocity of the car after the jump. Very easy. Momentum of the car will be mass of the car into velocity. Momentum, since no external force is acting, momentum is conserved. Initial momentum is equal to final momentum, means conservation of linear momentum. Okay, one more thing. In this chapter, you need to specify this linear and rotational or not, because rotational is also there, no? So linear momentum. So if that's the case, we can say mu is equal to mv, velocity is equal to mu by capital M.
M.
Got it? That's all. Okay, in the center of mass, this much is in detail. We have done a lot. Usually the center of masses are asked in the exam. I'll share an assignment with you. Still the assignment thing has not been corrected, no? That is
No,
not
this
working.
This time I haven't checked the assignment, ma'am. Today I had my class assembly. I was part of the assembly, so I was very busy this week.
Okay.
So I did
Okay,
not check the
assembly is over.
assignment.
Today is over?
Yes, today was the assembly.
Okay. So check it tomorrow and let me know in the next lesson, because
Okay.
we'll have the class in the next week. And that will be the last week before your exam. So we have to see that also. Anyway, just completes a major portion. Center of mass is a major portion. Tuesday,
Okay.
Monday we'll have the class now. Please write.
Okay. Done, ma'am.